Okay, now that we know about the future value of an annuity and we understand that, and we understand the time value of money, we have a lot to help us to understand what is the present value of an annuity. Okay, so if I were to simply draw a timeline, and on this timeline I tell you that this is time 0, this is the present time, and in every month you are going to make a deposit of X into a bank account earning I interest per month. Okay, and this goes on all the way up to sometime in the future where you make your final investment. Okay, and this is then called an annuity because it's a recurring investment, and the formula for the future value, in other words, how much will the value in the bank account be at the end of that time period, was given by this formula: 1 plus I to the power of n minus 1. Hopefully you know it off by heart by now. Okay, but that is the future value. And actually how we got that future value was to compound every payment to the future and add all of those up together. So how much will this value be worth at this time? How much will this value be worth at that time? This value at that time, that value, and every one was compounded to get a value in the future. So to find the past or the present value is kind of like asking, what will you give me if I promise to give you, let's say, 100 Rand every month for a whole year? I promise every month I will give you 100 Rand for a whole year. How much will you give me right now? And if you tell me you'll give me 1200 Rand, in other words, you'll give me all of the money that I'm going to give you, you'll give me now, you won't be charging me any interest. Okay, that would be a very kind of you, because I will be getting all of the money I only get in the future, I'll be getting it right now. If you were to charge me interest, then you would give me less than 1,200 Rand. So you would say, I think that promise is only worth 1,000 Rand. And then you actually earn some interest, because if I pay you back everything, you will get 1,200 Rand back, but you only gave me 1,000 Rand. Now that whole thing, this value at this time, the 1,000 Rand, is the present value of the annuity. Now, how will we get that? Well, there's two ways to look at it. I can either take every amount and discount it to the present time, but that's going to take incredibly long, especially if it's something like monthly investments for 20 years. Okay, what I can also do that will be much quicker is to take the future value of the annuity and discount only the future value. Okay, so let's go and look at that. If I were to say the present value is equal to the future value that is discounted. How do we discount again? We take it back with a negative exponent. That's the discounting. Okay, but we know what the future value formula is. This is the future value formula, so we just substitute it in. Minus 1 over I, and this is discounted with the same number. Remember, n represents the number of payments made, and since there's a payment made every term, that's how many terms I'll have to discount it with. Okay, so that's why it remains the same value, n, but negative, because I'm finding the past value. And there we go. There is already a lovely formula that is quite simple, but we can actually simplify that formula even more. Let me show you how. All I'm going to do is to distribute this bracket inside this top bracket. So that gives me an x. Okay, I've got 1 plus I to the power of n that is now multiplied with this bracket 1 plus I to the power of negative n. Okay, and I hope you can see what's happening. Here I have a 1 that is, the bracket is being distributed to that 1, so it's just negative 1 times 1 plus I to the power negative n. And that all happened in the numerator, nothing happening in the denominator because I'm multiplying. Okay, so now what is happening? Okay, look here, I've got same base, 1 plus I, which means I can add the exponents. But if I add the exponents, n minus n gives me 0. And anything to the power of 0 is just 1. So I have just 1 minus 1 plus I to the power of negative n over I. And there we go. This is from now on called the present value of an annuity of n payments. That's just a little footnote to say that's how many payments there's going to be. Of n payments into an annuity fund, this will be the present value. Well, I hope you can easily derive this formula by yourself. Let's have a look at the practical applications of this in the next video.